been on linear equations. We've solved linear equations. Now we're going to graph linear equations. And we've done a little bit of graphing before with our library of functions. So you're supposed to know that a graph is just a picture of all the solutions to an equation. Thank you so much for taking care of that for me. It's just a picture of the solutions. If I give you the equation y equals x plus 1, there are infinitely many ordered pairs where the y is one more than the x. And a graph is just a picture of all those ordered pairs. So in the library of functions, we graph the line y equals x as one of our basic functions that we were just going to know. We're going to take that line now and shift it around and change its direction. Talk about what accomplishes those things. First, we need to talk about the slope of a line, and the slope or steepness of a line is the ratio of its rise to its run, how much you go up for each unit you go over. Basically, it's the same thing as the slope of a mountain to a mountain climber. It's the rate of ascent for each unit of forward progress. Let's figure out something about slope by going through these problems that I listed, A through F. First, plot these 2 points, points P, -1, -2, and point Q, 1, 6. Plot those 2 points. And connect them with your very best line you could do without a ruler. Ooh, mine was about to be off. Wow, is off. We have a line that's going uphill from left to right. What does that tell you about its slope? It's positive. A line that goes uphill from left to right has positive slope. A line that goes downhill from left to right has negative slope. Now, let's say we didn't know anything about the slope formula. We've never heard of this formula. We just know that slope is rise divided by run. How would we get the rise, or how many units would you have to rise vertically to get from this point to the same height of that point? You could just count them. You could say 1, 2, 3, 4, 5, 6, 7, 8. We went up 8 units to get from the height of this point to the height of that point. So the rise from P to Q is 8. But how else could we have found that rise other than counting like I just did? What gives us the difference in height in 2 points? What specifically? The y's. The y's values tell you how much to go up or down from the x-axis. So if you want to find out how much you have gone up or down, then you would just subtract the y values. The 6 minus -2 would have given you that same 8 from subtract the y values. And then to get the run, or the horizontal distance from this point to that point, we've started to the one to the left of the y-axis and gone over to, what was this other point, 1, 6. How many horizontal units is it from -1 to +1? 2. How could we have found that same horizontal distance without having to count it on my very badly drawn graph? Yep, I'm gonna have to call for names. Subtract your x's would get the run. Your 1 minus -1. Give you the same 2 from subtracting your x values. So the ratio of the rise to the run is just the fraction with the rise in the numerator and the run in the denominator. The rise to run is 8:2. Or you could reduce that to just 4. You could say the slope of that line is 4. If you wanted to keep that 4 as a fraction, you could put it 4/1, which means you rise 4 and run 1 to get from any point to any other point on the graph. Now, technically, what I just said is not true. If I start here and rise 4 and run 1, I'm not at this point, I'm at this one, but it's still the same ratio of rise to run. It's still 4 units up for each unit over. So without graphing, the rise over the run is just what we said here. Subtract the y values, subtract the x values, and then form that ratio. The rise over run is just the difference in the y values over the difference in the x values. And those little 1s and 2s are subscripts, not, yeah, I'm not sure what I wanted to say they're not. They're definitely not exponents, they're subscripts, and that just means the second y minus the first y over the second x minus the first x. Okay? You were looking like you were confused about something. That's why I asked. Is something bugging you?
Oh no, I just.
Oh,
So I'm
no.
still kind of
Okay, all right.
processing.
Hang around a minute after class if you need to. Okay, so if P is some point x1, y1, and Q is some point x2, y2, as long as the x values are not the same, you can find the slope of the line between those 2 points using that formula we just came up with. The difference in the x's, or excuse me, the difference in the y's over the difference in the x's. So in the first example, I have given 4 different sets of points, and I want you to graph the line containing those points all in the same Cartesian coordinate system right here. I doubt that I have 4 colors with me. Ooh, I think I do have 4 colors with me. You probably don't. But just label them if you can't graph them all in different colors. Line 1 is from the point 2, -1 to the point 4, 3. Very best line without a ruler. Slope of that line would be the difference in the y values, 3 minus -1, over the difference in the x values, 4 minus 2. That simplifies to 4/2. So we would say that that line has a slope of 2. Now, I want you to help me answer one question before we go any further with that formula. How do you know which is the first point x1, y1, and which one's the second point x2, y2? Is there a way to? What if instead of saying 3 minus -1, what if I had said -1 minus 3? What would I have gotten in the numerator? I would have gotten -4 instead of +4. So maybe it does matter. But if I subtracted the x's in the same direction, 2 minus 4 would be -2. What's -4 over -2? It's still +2. So the point of that is saying it doesn't matter which one you call your first point and which one you call your second point, as long as you subtract both coordinates in the same direction. You couldn't say 3 minus -1 for the y's and then 2 minus 4 for the x's. They both have to go in the same direction. All right, line 2 goes from the point 2, -1. Starts with the same point P here. And -1, 4. Like that, line 2. Is for me. You go ahead and graph these other 2 lines and find all 3 slopes. Let's see if we all come up with the same thing. Oh, I do. No, I have mine. I don't know why. C is line 4 and D is line 3. I have no idea. Thank you. You gotta fix that before next time. If you had to use an adjective to describe your line 4, Do you have line 4 going straight across? What do we call that kind of line? Straight line, but they're all straight lines, that wouldn't do. What do we call this? Horizontal, it's a horizontal line. And that's actually, the one in the part C, line 4 was part C. What did you get for the slope of that line? When you use the slope formula, you came up with 0/4. And you're never gonna leave 0/4 as the answer to any problems in this class, because you know what 0 divided by 4 is. 0 cookies divided by 4 children. How much cookies does a kid get? 0. So the slope of that horizontal line 4 is 0. Now, if you had to use an adjective to describe your line 3, does your line 3 go straight up and down? Yeah. How could you describe that line? It's vertical. And by the way, y'all, that is, well, I'll spell it over here in a minute. I want to make sure you're spelling vertical correctly. Line 3 is a vertical line. And when I used the slope formula, I came up with 6/0. You do not want to lose half a letter grade on the test because you left 6/0. You're going to tell me 6/0 is what?
6.
Well, if you know what, I can check both of those answers. I heard 0. Does that check? Does 0 times 0 give you 6? No, it doesn't. So that can't be right. And then I heard 6. Does 6 times 0 give you 6? No, that's undefined. Because there's no number that you could put down and multiply by 0 and get 6. So make sure you remember division by 0 is undefined. And put that down for the slope of that vertical line. Now, in looking at all 4 lines, let's answer these questions. When the slope of a line is positive, which one of our lines had a positive slope? Line 1 did. How would you say that line slants with its positive slope from left to right? It's going up from left to right. When the slope of the line is positive, the line slants upward. And really, to be perfectly precise, I want to say left to right. Because if we looked at it right to left, we'd be going downhill. And then line 2 had negative slope. And when the line has negative slope, the line slants downward. Left to right. And then our line 4 had 0 slope. And what word did we use to describe it? That's a horizontal line. And the slope is 0. We have a horizontal line. And then line 3 was the one we said the slope was undefined. And you told me that was a vertical line. So here's where I want to make sure you're spelling it with C-A-L, not C-L-E at the end. We can tell something about how the line looks just by knowing whether the slope is positive or negative or 0 or undefined. All right, the next thing is drawing lines when I'm given a point and a slope. Both of these, I want to go through the point -3, 2, but I want my line 1 to have a slope of 2 and my line 2 to have a slope of -4/3. So let me plot that point -3, 2. What does a slope of 2 tell me to do from that point? How do I get another graph when the slope is 2?
Go over.
That would be run over rise, and slope is rise over run. So, yeah, you just had it backwards. That 2 is my rise. And if I want to write the slope as a fraction, I can put 2 over 1 and see that 1 is my run. So I would start at that point and go up 2 to the right 1. And that's another point on the graph. So here's my very best line 1.
If one of them was negative, then would you go?
That's my very next question. You're good at anticipating. What if the slope was negative? Just don't write this down on your paper, but let me quiz you for a second. Of these 3 things, well, are those 2 things the same? They're both -0.5, right? Is this the same thing? It is. It's also -0.5. Now, we usually don't write a negative in the denominator of a fraction. If I had a negative in the denominator, I'd just bring it out front. But if I punched all 3 of those on my calculator, I'd get -0.5. So they're all the same. What about this? That's not the same, because a negative divided by a negative is a positive. If you did write that down, make sure you put a big old not equals through it. And then back down here in the B part, the reason that I showed you this was to say that when the slope is -4/3, you can either think of it as -4 over +3, or you can think of it as +4 over -3. All 3 of those things are the same.
Are you gonna get the same answer?
Well, let's see. Let's do both and see if we get the same thing. Let's start at this point, -3, 2. And if I think of the negative as being in the numerator, what do you think negative rise means? Down? So down 4, and what do you think positive run means? To the right. Let's start here and go down 4 to the right 3. 1, 2, 3, 4. 1, 2. My eyes are getting better. 1, 2, 3, 4. 1, 2, 3. So that's if I went down and to the right. What if I had started at this point -3, 2, and instead of going down and to the right, I went up 4 and to the left 3? Would I still get the same line? Let's see, starting at the point -3, 2, go up 4. And to the left 3. So yeah, I would get the same line. That's my line 2. Whether I went down and to the right or I went up and to the left, I would just get a different and wrong answer if I had gone down and to the left. All right. Any questions? Good. Three methods for graphing linear equations. Now, I've talked about that word linear before. How do you recognize a linear equation? What about this equation makes me go, oh, that's linear? There's something a little bit more specific than that that I can say. I'm glad you remembered that. But a linear equation, the highest exponent is 1. Linear means first degree. When you graph a linear equation, well, number one, you can recognize that it's a linear equation, and then to graph it, you know it's going to be a line. The first way you ever learned to graph lines was by making a table. And then you should have learned after that that there are faster ways than making a table. But just to review, making a table, choose X values, substitute them in to find the Y values. How many points do I have to have? What's the minimum number of points with which I can graph a line? I have to have 2 points to graph a line. I usually pick 3 X's, and if the third one's not in line with the other 2, I know there's a mistake somewhere. I've got to go back and check all 3, but I usually pick 3 X's. Now, is there a magic to help me decide what X's to pick? Doesn't matter what X's I choose. Everybody in here could have 3 different X's and we'd all get the same line as long as we calculated our Y's correctly. So I'm usually boring and pick -1, 0, and 1 just because they're easy to plug in. And when I say plug in, I'm saying put each value into that equation. If you let X be -3, then Y will be -3 times -1 plus 4, which is 7. And we have found one ordered pair that's on that line. The ordered pair that we have found is -1, 7. If I let X be 0, I'll have Y is -3 times 0 plus 4, which is 4. I found another ordered pair on that line. And if I was lazy, I'd stop right there, plot those 2, call it done. But I'm not lazy. I like to check things whenever I can. So I'm going to choose a third X value, chose 1, and substitute it into the equation. Reordered pairs I can graph, and all 3 are on the same line. I feel pretty good that that's the right answer. -1, 7 is off of my graph, and if that happens on the test, that's okay. Just come up here, put a dot where you think 7 would be. On the y-axis, and here's 1, 1. Is my very best graph of that line. If one of you had chosen X equals 2, you would have come up with Y equals -2. 2, -2 is on the same line. Or if one of you had chosen X equals -1, you would have come up with Y. Oh, I did choose X equals -1. If I had chosen X is -2, I would have come up with Y equals 10. The point -2, 10 is up here off my paper, but it's still on the same line. So all 3 of us, or all of us, could have 3 different ordered pairs we should all have the same line. All right, that's the slowest way to graph. Two faster ways to graph require your knowledge of two different forms of an equation. And before I can talk about my slope and y-intercept or y-intercepts, I need to skip down here for just a minute. And Justin, who's beside you? Yeah, Isaac. Isaac, now we're coming to what you said. You recognize that having the y by itself was a special form of an equation. That special form is called slope-intercept form because that's the two things that you can tell just by looking at the equation. If you have a linear equation with the y by itself, the coefficient of x, the number in front of it, the x, is the slope. The constant is the y-intercept, where the graph crosses the y-axis. Real handy for graphing, like in example 2, y equals 2x minus 1. Just by glancing at that, you can look at it and tell me, number one, it's going to be a line. Tell me how you know it's a line. Degree. It's linear. So I know it's going to be a line, and I know that because the y is by itself, this is slope-intercept form. What's the slope of that line? 2, and if you want to write it as a fraction, you can put it 2 over 1. By the way, I didn't mention it on the front of the page. The word or the variable that stands for slope when we're talking about linear equations, slope is always signified by m. When I write m equals something, I'm talking about slope. I don't know why. I suspect maybe the Latin word for slope starts with an m. Yeah. So you said the slope was 2 or 2 over 1. I'm going to write it m equals 2 over 1. And then the y-intercept is what? I love that you gave me the whole ordered pair. I was expecting someone just to say -1, and that would be correct. The y-intercept's -1. But since you're fixing to graph it, I think it may be helpful to write that as an ordered pair. 0, -1. That's where the line crosses the y-axis. So I'm going to plot that point, 0, -1. Just like we did on A and B at the bottom of the page. I can start at the point that I'm given and then count out the slope, rise over run. That slope being 2 means 2 is the rise and 1 is the run. I can start at 0, -1 and go up 2 to the right 1. And that'll give me a line that's going uphill left to right, which is something I know I ought to have with a line with positive slope. B part of that example is actually the same equation that I just made a table for, but I told you making a table wasn't the fastest way. I just want you to see how much faster it is to identify the slope and the y-intercept. What's the slope of that line? All right, -3, and I'm going to write it as a fraction, -3 over 1, where my rise is -3 and my run is 1. Or I can put that negative in the denominator and say my rise is positive, my run is negative. But we already figured that out. What's my y-intercept if I write it as an ordered pair? 0, 4, perfect. Is 0, 4 what I got for the y-intercept when I made a table? Yeah, but it's faster just looking at that in slope-intercept form and saying, well, your y-intercept is 4. From that point, I need to rise -3, otherwise known as fall 3, and run 1. If I messed up and said down 3 to the left 1 and drew that line, would it be a line with negative slope? I'd be going uphill left to right. I know that can't be correct. Make it go down 3 to the right 1, and I have the same line I got by making a table, but much faster. Any questions? All right. The third way of graphing comes in handiest when your equation is in general form. I haven't yet told you what general form is, so zip back down here for a minute. General form is when your x and y are on one side and your constants on the other. You give me an equation in that form, then the easiest way to graph it's going to be finding both intercepts. Now think back to actually some problems in last night's homework. How did we find an x-intercept? If we were looking at the graph, it's easy. It's where the graph crosses the x-axis, the y-intercept is where the graph crosses the y-axis. But if we're looking at an equation, how do we find the x-intercept? Let y be 0, because if you're sitting on the x-axis, y is 0. How do you find the y-intercept? Let x be 0. If you're on the y-intercept, x is 0. So we said this before in both lesson 3 and lesson 4. We said let x be 0 to get the y-intercept, let y be 0 to get the x-intercept. Now the reason that's so easy when the equation is in standard form, when your x and y are on one side, I said standard, this book calls it general. When your x and y are on one side and your constants on the other, you can just put down 2 parentheses, pairs of parentheses. Let x be 0 in one of them, let y be 0 in the other one. And when you let x be 0, what happens to this first term? Just cover it up. You can solve 3y = 6 in your head. If x = 0, y has to be what? 2? That's your y-intercept. When you want to let y be 0, what's 3 times 0? 0, just cover up the y term. And say, if negative x = 6, then what does x equal? -6. Just divide both sides by -1. So super easy to find the intercepts when your equation is in this form. And that's all you need to graph it. 0, 2 is on the y-axis. -6, 0 is over here, just a little bit off the left side of my graph. Pretty easy. You give me an equation in general form and just say graph it using any method you want, I'm going to find the intercepts. So the B part, it's in general form. I try the same thing. I'd let x be 0 and let y be 0 in 2 different ordered pairs. Let x be 0, if you just cover up the X term, what do you get for Y? Zero divided by 2 is 0. What if you let Y be 0? Cover up the Y term and you get X equals 0. Is that enough to graph the line? That's only 1 point. I can't just graph the point 0, 0 twice and then put a line through it. I have to have another point. How would I get another point? Equation. If I gotta have another point, what could I do? Well, you can't pick both the X and the Y. You can pick X and find Y, or you can pick Y and find X. But you can't pick them both. You gotta pick one and then find the other. You could, what did you say first? Let X be 2? All right, but let's check this. If we let X be 3 and we let Y be 2, we'd have 9 plus 4. Does 9 plus 4 equal 0? No. So 3, 2 is not a point on the graph. How can I find another point on the graph? All right, there's actually 2 things I could do. What you were suggesting, Taylor, was like making a table, just pick another X, plug it in and find the Y. But Isaac's going back to his, I really like slope-intercept form. And I really like slope-intercept form also. I would just solve that for Y. I would subtract 3X from both sides. And then I would divide by 2. And then my equation's in slope-intercept form. Intercept form, I can see that the y-intercept is 0. There's no constant added on the end. But in addition to being able to see that the y-intercept is 0, I can see that the slope is -3/2. Which means I can start at that point 0, 0, count down 3 and over 2 to find another point on the line. When I have no idea what a graph's going to look like. And this is how we started lesson 3. That had the library of functions. I played like I didn't know what any of them was going to look like, and I made an XY table for all of them. But that's not the fastest way. The faster ways are either using the point and the slope if you're given, using the slope and the y-intercept if an equation is given to you in slope-intercept form, or finding the x and y intercepts if your equation is in general form. But there's still a possibility if the line goes through the origin, then both intercepts are going to be 0, 0, and you're going to have to drop back and use some other method of finding that second point. All right. Any questions? And it made me making you yawn. It made Isaac, I caught you yawning a minute ago. Even if you've seen it before, there are probably still some things that you have to brush up on, the different forms of an line, just to be able to do the homework. There's a tiny bit of memorizing here. You need to know the different forms of the equation of a line and the slope formula. Let's see. I've got a highlighter in me. I would highlight the slope formula. it's rise over run, then you can figure out the formula. It's the difference in the y's over the difference in the x's. And you also need to know general form is where your x and y are on one side, your constants on the other. And that's easiest for finding the intercepts. Need to know slope intercept form is when the y is by itself. And that makes graphing really easy. So let's go back and talk more about this horizontal line and vertical line that we got on the front of the paper. That vertical line, I said the wrong thing. That horizontal line, that was my line 4. That came from my C part because of my weird numbering. What do you notice about those 3 ordered pairs? I can't even count ordered pairs. It may be time to retire. What can you tell me about these 2 ordered pairs that would give me a clue as to why that came out to be a horizontal line? The y's are the same. And if you think about the line where all the y's are the same, that's got to be going straight across. Your height isn't changing. Your y values always represent your height. And if your height is a constant, then you're going straight across. That's always going to happen when your y's are the same. And then this vertical line, the green line, 3 that came from the D part, what's the same about those ordered pairs?
Yes.
The x's are the same. Now, x's tell you how far to go left or right. If your x is the same thing for every point on the line, you got to be going straight up and down. So it's when the y's are the same that you get a horizontal line, and a horizontal line has 0 slope. It's when your x's are the same that you get a vertical line, and a vertical line has undefined slope. I have a corny little acronym to help you remember everything you need to know about horizontal and vertical lines. I'm all for corny when it works. If you have y equals a constant, your height is not changing, that's a horizontal line. And horizontal line has slope, 0 slope. You can remember those 3 things with the corny acronym HOY, H-O-Y. Stands for horizontal line has 0 slope, and the equation is y equals a constant. You can memorize everything or know everything you need to know about vertical lines with the acronym BUX, B-U-X. When x is a constant, your leftness to rightness is not changing. You're going straight up and down. And the word we use for that is that's a vertical line. And we saw on the previous side of the paper that a vertical line has undefined slope. There are either, I'm going to say probably 2. There are probably 2 problems on the test that are something about horizontal and vertical lines. If this is a 20-point or 20 problem test, how many points is that per problem? 5 points per problem. If you miss the 2 problems about horizontal and vertical lines, how many points is that? That's a letter grade. We're not remembering HOY and BUX. We're not just thinking about it really hard. It's not even really all that hard. Y equals -3. You can think, well, y is a constant, so it's a horizontal line. The faster way is just to say y is -3 no matter what x is. If x is -1, y is -3. If y is 0, if x is 0, y is -3. If x is 1, y is -3. That's the height of the graph not changing whether x was -1 or x was 0 or x was 1 or way over here x is 5 or way over here x is -5. They all correspond to the y value -3. And that's why it's a horizontal line. Now, all I asked you was to graph it, but if I did ask you for the slope, what's the slope of that line? Yep. Equation x equals 2 is saying x equals 2 no matter what y is. Y can be anything, and x is always 2. Think about all the ordered pairs where x is 2 in the Cartesian coordinate system. Here's 2, -1. There's 2, 0. Here's 2, +1. Here's 2, -4. Here's 2, +4. All those points are on a vertical line. So x equals a constant always gives you a vertical line. And I didn't specifically ask for it in this problem, but if I did ask you for the slope of that line, what would you say? Undefined. Slope is undefined. I started a sentence a minute ago that I forgot the end of it. I just remembered the end of it. Make sure that you never use the phrase no slope to describe slope, because I don't know which of these two things you mean. If you say no slope, do you mean 0 or do you mean undefined? I don't know. Slope is a fraction. If you have 0 in the numerator of a fraction, that fraction is equal to 0. If you have 0 in the denominator of a fraction, we say that's undefined. We never say some fraction equals the word no. So don't use no slope. All right, we have graphs. Lines with positive slopes, lines with negative slope, horizontal lines and vertical lines. There's about 3 other big things in this section. Big number 1 was graphing. Big number 2, what if instead of giving you the equation and asking you to graph it, what if I gave you some information about the graph and asked you to find the equation? That's when you use point slope form. You use it 99% of the time if the directions say find the equation of the line. Now, if I took this equation, again, these two little ones are subscripts, x1, y1, they're subscripts. If I solve that equation for m, how could I get that m by itself? Could distribute it, but that would make it a little bit harder. If I distributed the m, I'd have to turn around and factor it back out. I could divide by the x minus x1. And if I did, what would this left-hand side look a darn lot like? Y minus, that would be my slope formula. All right, this is just the slope formula with both sides multiplied by the denominator to clear out the fractions. The x1, y1 is the point that I'm given. And the M is the slope. So if you give me a point and a slope, it's automatically gonna pop in my head, use point slope form. That's why it's named point slope form. Given a point, you give it a slope. You plug that into this formula, the X and Y without subscripts, they're the X and Y that stay in the equation. They end up being your X and Y in the equation. The X1, Y1 is the point that I'm given. So Y minus the Y value of the point I'm given equals the slope times X minus the X value of the point that I'm given. Let's use it. Example, say, find the equation of the line with the given properties. I'm going to give you some information. You're going to find the equation of the line, and the directions say, write your answer in slope-intercept form. I think I was careful in the homework and only chose problems that said, write your answer in slope-intercept form. I want you to get the Y by itself, but it may not start out that way. All right, number one, I'm given two things. I'm given a point and I'm given a slope. What form of an equation am I going to use when I'm given a point and a slope? Point slope form. That's why it's named point slope form. So to help me get it memorized in case I don't have it memorized already, I'm going to write down the words and the formula on every problem until I'm sure I have it memorized. And then I'm going to say the point that I'm given is my X1, Y1. The slope that I'm given is my M. And I'm just going to plug those three numbers into the equation. Y minus 1 in the place of Y1 equals 1/2 in the place of M times, in parentheses, X minus X1. X1 is 3. If the direction said, leave your answer in point slope form, I'd be through. That's point slope form. But the direction said, get your answer in slope intercept form, which means get the Y by itself. So on number one, what's the two things I would have to do to get the Y by itself? Distribute the 1/2 and add 1 to both sides. If you could do both of those things at once, yay, it would save you one line. I'm going to distribute the 1/2 and add 1 to both sides. And then if you can clean it up, you should. In my happy bubble, all of you can add -3/2 plus 1 in your head. But if that's not accurate, then you need to know how to punch -3/2 plus 1 on your calculator. And if you don't, come up here after class with your calculator and I'll show you how easy it is. I want you to miss one just so you don't add fractions in your head or enter them on your calculator. That's my answer in slope-intercept form. All right. Number 2, I'm not given a point and a slope. I'm given a point and another point. Do I need a new form, the point form? Why not? what can I do? I can find the slope. You give me 2 points, I'll find the slope. The slope is y2 minus y1 over x2 minus x1. And I'm illustrating something important to you here. Writing down the words and the formula on every problem is how you get the words and the formula in your head where you need it. I'm going to call this first point my x1, y1. And I'll call that second point my x2, y2. Really doesn't matter which one I call my first point, which one I call the second point. Plug those into the slope formula. Y2 minus y1 is 5 minus 4. X2 minus x1 is 2 minus negative 3. Clean those up as much as possible, and you get the slope of 1/5. That the answer to this problem? I wasn't asked to find the slope, I was asked to find the equation of a line. I just had to find the slope in order to have the information I needed to use point slope form. And when you use point slope form, it doesn't matter. If we had more time, I'd let half the class use this point and half the class use this point and show that you both come up with the same equation. We're always rushed in here, so we don't have time to do that. I'm gonna eeny, meeny, miny, moe. Pick the point with fewer negatives. I'm less likely to make a mistake if I pick the point with fewer negatives. But if I use this point, I'd come up with the same answer. I'm going to substitute those values into point slope form. I minus the y you gave me equals m, which is my slope, times x minus the x that you gave me. And the two things I'd have to do to have that in slope intercept form, I have to distribute the 1/5 and add 5 to both sides. Can't do it in your head, and make sure you can punch it on the calculator. Oh, and I think I have these directions typed on the test, but even if I don't have them typed, leave that in improper fraction rather than writing it as a mixed number. Just about the only time we use mixed numbers in a math class or in an algebra class is if we're doing a word problem where mixed numbers would make more sense. For example, if I'm getting fabric cut at a fabric store, I'm not gonna ask for 23/5 of a yard. I would ask for 4 3/5 of a yard. That would make more sense as a mixed number, but otherwise I'm gonna leave that an improper fraction. All right, the next two were, well, 3 is very fast. 4, we're gonna set it up but not finish it. Number 3, if you give me a slope and a y-intercept, what's the easiest form of an equation to use? Slope y-intercept form. That slope is my m. That y-intercept is my b. So slope-intercept form y equals mx plus b. If I put -2 in place of the m and -2 in place of the b, I'll be through with this one. Y equals -2x minus 2. Number 4, I'm given both intercepts. I'm given the x-intercept is -4, the y-intercept's +4, and I don't have anything named intercept form. So, does anybody have any ideas for me? Oh, you could write both of those as ordered pairs. I know if the x-intercept is -4, that means the y is 0. And if the y-intercept is +4, that means the x is 0. Okay. So right here, I'm gonna say ... That's like number 2. Once you have 2 points, you can find the slope, and you could either use point slope form, or in this one, you could use slope intercept form. But you have to recognize that those are 2 points. The most common mistake I've seen folks make is write that as 1 point, -4, 4. That's not 1 point, that's 2 different points. And if you tell me that a line has undefined slope, what do I know that line looks like? It's vertical. And if you tell me a line is vertical, what does its equation look like? Is that when x is a constant gives you a vertical, or when y is a constant that gives you a vertical? X. X equals some constant. There it is. X equals some constant. And in this case, that constant is 3. It's just the line x equals 3. And if you tell me you want the equation of a horizontal line, what do I know its equation looks like? Equals a constant, or y is a constant that gives you horizontal. Because that's the rise or the height of the equation, and if all the height's the same, you've got a horizontal line. Y equals a constant, and in this case, your constant's -5. So y equals -5 is the equation of the horizontal line that goes through that point. All right, got to speed up just a tiny bit. 2 more things: parallel perpendicular lines, and then those 2 word problems. 3 word problems on the back. We'll see what we can get done. What you need to know about parallel lines is that they have the same slope. Excuse me. That's why they never cross. For each unit they go up, they go the same amount over, and they never cross because they have the same slope. Perpendicular lines, show me with your arms what I mean by perpendicular lines. Cross at a right angle. Of course, it can be that, as long as your arms look like they're touching at a 90-degree angle. The reason perpendicular lines are perpendicular is their slopes are 2 things. They are opposites and reciprocal. Parallel lines, the slope are the same. Perpendicular lines, the slopes are opposites and reciprocals. So if I tell you one line has a slope of, say, -2, what's the slope of a line parallel to it? Same thing, -2. But if I tell you a line has a slope of -2 and ask you for the slope of a perpendicular line, what would it be? +1/2. Opposite means change the sign, reciprocal means flip it. So on number 1, and you would be running out of time, so I gave this to you in the form. You can go ahead and tell me the slope of this line is what? Yeah, it's in slope intercept form. The slope is -3. Now the symbol for parallel is 2 vertical lines that are parallel to each other. And the symbol for perpendicular looks like that. So I'm going to say a line with slope of -3 is parallel to a line with what slope? Same thing, -3. And if I use this point and this slope, what would I plug them into? Get the equation of the line. And a point and a slope, so I'd use point slope form. Now, some of you are used to using slope intercept form for everything. And if that's the way you learned it and you consistently get the right answer, I'm not going to argue that my way is better than your way. I'm just saying, if you don't already have some other way of finding the equation of the line, if you give me a point and a slope, I'm going to use point slope form. Fast. Y equals -3x minus 1. All right. Number 2 is just a little bit different for 2 reasons. First reason is I'm asking you for a line that's perpendicular to the line I'm given. And the second thing that's different is I can't just look at this in this form and tell you the slope. I can't say the slope is just the coefficient of y until I get the y by itself. So I have to solve this one for y to find the slope. I would subtract x from both sides. And then I divide both sides by -2. Just to make it easier on your eyeballs. I'm going to divide each term by -2. And what's the simplest way to write -x over -2? What is that? X divided by 2 is not the same as x times 2. 1/2 x. The coefficient of this x is -1, and -1 divided by -2 is +1/2. I realized you're answering a different question. You were one step ahead of me. The slope of this line is 1/2. So the slope of a line perpendicular to this line would be what? -2. You did opposite and reciprocal. What can you tell me about this point 0,4? What's special about that point? If x is 0, it's my y-intercept. And if I have my slope and my y-intercept, I could plug it into point slope form, but it would be easier just to plug into slope intercept form. Point slope form would have given me the same thing. All right. These next two, super easy. Show me with your arm the line y equals 5. Which one is it? Y, the y is always 5, is this. The height is not changing. Now show me with your other arm a line that's parallel to this one. And if it goes, and what's the equation of these horizontal lines? Is it x equals something or y equals something? Y equals, and if it's going to go through the point 4, 2, what does y have to equal? It would have to equal 2. Both of these are horizontal lines. This one goes through the point 4, 2. And number 4, the line y equals 8. Perpendicular to that, show me a line that's perpendicular to this one. What's the equation of this line? X equals something, and if it's going through the point 3, 4, what does X have to be? Yeah, I'm going to just have something to put in your notes. I'm going to say this is horizontal, so perpendicular would have to be vertical. And if it's going to go through this point, it has to be X equals 3. So I'm not plugging anything into any formula. I'm thinking horizontal line, vertical line, X equals whatever X equals. As always, we have run out of time with problems left to go. I am going to stay and record these 3 problems just in case you need to look at them tonight. Let me tell you on 2 of them, to get the equation of a line, you either have to be given a point and a slope, or you have to be given 2 points. These first 2 problems, you're given a point and a slope. This last problem, you're given 2 points. So I'm going to stay and record those. It'll take about 10 minutes. So if you need to watch them before you start your homework, click the link in Momentum and watch the last 10 minutes of the video. I'll have it up shortly. All right, y'all have a great day. Be working on that practice test. Test days are coming fast. Hey, you gonna hang around and be in the audience? Yay, I'm in the audience. All right. Like I said, to find the equation of a line, you either have to be given a point and a slope, or you have to be given 2 points. So read each problem and figure out what it is that you're given. Number 1, the fixed cost of a business are the costs incurred regardless of level of production. If you're in manufacturing, there are certain expenses that you have to pay whether you turn the machines on or not. You have to buy the machines, you have to buy the materials for manufacturing, whatever. No, I'm sorry. Take that back. Your fixed costs are like the rent on the building. You have to pay the same rent whether you turn the machines on or not. The cost of the machines themselves, those are fixed costs. Variables depend on how many things you're making. That's variable costs. So like your electricity could depend on how many things you're making. And your raw materials like denim, if you're manufacturing jeans, your cost of denim is going to depend on how many pairs you're making. So fixed costs and variable costs. Variable costs depend on how many things you're making. Suppose that a manufacturer of jeans has fixed daily cost of $500. That is what the manufacturer is going to have to pay whether they make any jeans or not. That's your fixed cost, $500. And on top of that, the manufacturer's costs are $8 per pair of jeans. So if they make 1 pair of jeans, that's just going to be $508. If they make 2 pairs of jeans, it's gonna be $516. What if they make X pairs of jeans? How would you get the variable cost if you made X pairs of jeans at $8 a pair? 8X. The 8X plus 500 is the equation we were looking for. I think the reason I left 2 lines there is probably to say that variable costs are cost per pair times number of pairs. I think that's what my second equals was supposed to say. And so the equation that I'm looking for is C equals 8X plus 500. Now, I said you had to be given either a point and a slope, or you had to be given 2 points. In this problem, we were given a point. 500 is my fixed cost, and my slope is 8. So 8X plus 500 is the equation of the total cost. And then the B part says what is the cost of manufacturing 400 pairs of jeans? If you give me a number of pairs of jeans, I'm going to put that in place of X. I could have asked you how many pairs of jeans could you make for $4,000? Then I'd be giving you a cost and you'd be solving for X. With this particular problem, you're giving me an X. So I'm just going to plug it in. 8 times 400 plus 500. The 3,200 plus 500 or $3,700 to make 400 pairs of jeans. Right? That one's very straightforward. Number 2, Dan works at a car lot. And he gets $375 just for showing up. He can show up and sit all day in the break room and he still gets his $375 until he gets fired. In addition, he receives 5% of profit on any sales he generates. So if he sells, to make the math easy here, $100 car, you couldn't drive a $100 car off the lot, but if he sold a $100 car, then 5% of 100 is $5. He would get $5 in commission plus his $375 just for showing up. He'd get $380 that week if he sold a $100 car. His total pay is his, we could use the same words here, really. Instead of fixed cost and variable cost, he has fixed pay and variable pay. And his fixed pay is the $375. His variable pay is 5% of his sales. That part of his paycheck depends on how many dollars worth of cars he sells. And fixed pay is $375. So if I let X be his amount of sales, how do I get 5% of X? You tell me, David? Yeah, you change that percent to a decimal, 0.05, and then multiply 0.05 times X plus his fixed pay. So it looks very much like our previous problem, the cost equation. Instead of cost, this is pay, but I was still given a point and a slope. So, I used, well, actually, I was given a y-intercept and a slope, so I used, slope-intercept form to find that equation. And then the B part says, how many dollars of profit would Dan have to generate in sales in order to earn $500 in a week? Is that 500 my X or my P? That's the pay that he wants to get, so they're giving me the value of P. And I have to solve for X. $375. And then divide by 0.05. Oh, this is embarrassing. I'm just drawing a blank there. It would be 5,000. 10% would be 500, 5%. No, it's not 5,000. Yeah, I'm just kind of embarrassed there. Once I start drawing a blank, there's no recovery. Yeah, 10% would be 250, so 5% would be 125, extra 2,500. He needs to sell $2,500 worth of cars, and we're gonna pay $500. Cheap car, cheap take home pay. I think he could live on that 500. All right, last one. We've had two examples where I was given a slope and a y-intercept. I bet this one I'm given 2 points, but let's see. A cereal company finds that the number of people who will buy one of its products in the first month that the product is introduced is linear related. That just tells you that it fits a line. I'm going to be able to use, come up with two ordered pairs and use the point slope form. It's linear related to the amount of money it spends on advertising. And you might have to read that first sentence 2 or 3 times to actually get what it's saying. But linear just means we're talking about a line. And it makes sense that the more the company spends on advertising, the more boxes of cereal it would expect to sell. At least the first month. After the first month, you might spend $1 million on advertising and your sales don't continue to grow at the same rate because it's not shiny annuity. But at least the first month, the more they spend on advertising, the more boxes of cereal they'll sell. If it spends $40,000 on advertising, then it'll sell $100,000 of boxes of cereal. Not dollars, just 100,000 boxes of cereal. If it spends $60,000 on advertising, then it'll sell 200,000 boxes of cereal. Write a linear equation that relates A to X. The way that's worded relates A to X tells me that X is my independent variable. When we talked about functions, we said X is your independent variable and Y is your dependent variable. Well, here A is my dependent variable, X is my independent variable. And what helps me a lot with these to make sure I set up both ordered pairs the same way, I'm gonna write in words what each ordered pair represents. The independent variable, the X, is a number of boxes. And the Y variable, or in this case, the A, is dollars spent on advertising. I guess the fastest way to write that would be ad dollars. So I just want to make sure that I have both ordered pairs set up, boxes, comma, dollars. The first ordered pair is number of boxes, 100,000 boxes. They would have to spend 40,000 on advertising. Second ordered pair to sell 200,000 boxes. Have to spend 60,000 on advertising. And that's the hard part right there, figuring out how to set up your ordered pairs. Once you have your ordered pairs set up, it's just like this 2 on the previous page. You give me 2 points, I can find the slope, and then I can use one of my points in the slope to get point slope form. But without talking anymore, I'm going to finish this out so you'll have the answer. The slope. Difference in the y's over the difference in the x's. Slope being 1/5. The units, that numerator is your dollars. So that's $1 in the numerator for 5 boxes in the denominator. For each additional dollar they sell in or spend on advertising, they're going to sell 5 boxes. Now that I have the slope and any, mini, miny, mo, either one of these 2 points, I can plug that information into point slope form. The only thing I might write differently about that, they told me to use A for the amount of spent on advertising instead of Y. To be technically correct, I need to call that A equals 1/5 X plus 20,000. Is that okay, Taylor? All right. Thanks for hanging around with me. And I hope that helps you with your homework. See ya Monday.